See chapter 1, exercise 1.4, sum 11. The distance s, an object travels under the influence of gravity in time t seconds, is given by s of t is equal to half gt square plus at plus b, where g is the acceleration due to gravity, a, b are constants. Verify whether the function s of t is 1 to 1 or not. So here the distance function is given, yes, distance as for distance in time t. So it is the function of t of g t square plus at plus b. S of t, distance in time t. See 1 hour in 2 hours, how much distance covered. Here g is given as gravity in t seconds, where a and b are constants, Here I have to prove s of t, to prove whether S of t is 1 to 1 or not. First you take the concept 1 to 1 function. What is 1 to 1 function? Every distinct element in the domain must have the distinct images in the codomain. See here, let me take the proof in the general case. I am not going to substitute the values for t. So for two different images, see it is a function, s of t is a function. So s of t1, that is what it stands for, the image of t1. S of t2, image of t2. See all these are in the codomain. S of t1 and s of t2 are images of and or elements of the codomain. I am going to prove if these two are equal, so t1 may be equal to t2, maybe, because the doubtful question asks whether you check whether it's 1 or not. So you will substitute the function. What is s of t? Half gt square but here t1 square plus at1 plus b. This is your s of t1 function. S of t2 function is half g t2 square plus at2 plus b. Okay, you collect the similar terms on the left side. Half g t1 square minus half g t2 square, and also at1 minus at2, and b, same b on the right side, is equal to 0. Here bb gets cancelled. For this here half is common, g also common. Take t1 square minus t2 square. Then take a is common, t1 minus t2 is equal to 0. See, what is this t1 square minus t2? A square minus b square. t1 minus t2, t1 plus t2 plus a t1 minus t2 is equal to 0. See, now we have only two terms. You look at the common terms in these two terms. t1 minus t2 is common. Bracket. So write the remaining terms. Half g t1 plus t2 plus a is equal to 0. See, now we have got the product of two terms. So the product of two terms, t1 minus t2 into half g t1 plus t2 plus a. the whole bracket term is one term, is equal to 0. So what do you mean the product of two terms? Either any one 0 means you will get the whole expression as 0. So 0 into 5, 0. 4 into 0, 0. So any one of the term may be 0. In that case, I take either T1 minus T2 is equal to 0 or of G T1 plus T2 plus A is equal to 0. See, when T1 minus T2 0 means you are getting T1 is equal to T2. See, you no need simplify this. You can just leave it off because we arrived at the answer T1 is equal to T2. When two images are equal, S of T1 is equal to S of T2, their corresponding pre-images are also equal. So, according to the definition of one-to-one function, distinct elements have distinct images. So, when S of T1 is equal to S of T2 implies T1 is equal to T2. We proved this. So according to the definition, distinct images have distinct images have distinct pre-images. So it is a one-to-one function. Thank you.